Welcome to Unit 1.2, Manipulating Functions. This part of the unit is called Transformation of Functions, and there should be an updated version of the table of contents on the wall behind my desk, just in case you wanted to take a peek at that to update your table of contents. Go ahead and title this page in your notes, Transformation of Functions, Unit 1.2. And I would like you to copy down what we're doing here together in the video into your notes. This is going to be helpful for you in this unit moving forward. So in this slide, we're going to start by talking about the different types of transformations for what we're going to call the parent function y equals f of x. And I know that some of this we talked about in the review together. A parent function is just the most basic form of a certain type of function. And in this case, by just calling it f of x, it means the most basic form of any function. And we're just going to write it in function notation. So whatever x we plug in, the function, whatever that function happens to be, will change it in some way, and our output is going to be called f of x, which is equal to our y value. The first type of transformation we're going to talk about is a vertical shift. Remember, that means that we're shifting our function up and down on the y-axis. So if I have a function and I want to shift it up and down on the y-axis, the way that I'm going to notate that in this general notation is y equals f of x plus k. That k value, that number being added to my function after all of the other function stuff happens to it, is the value of my vertical shift. So if that's a positive number, it means I'm shifting up. If it's a negative number, it means I'm shifting down. And the way that I can remember that the general version is called the letter K is if I take a look at the word vertical itself, I'm going to misspell it so that we will remember that it's a K. So vertical. So it's got that K sound in it. And that'll remind us that the letter K means up and down, okay? Vertical. The next kind of shift that we can have is called a horizontal shift, and this can be the most confusing type of shift. So the way that we note the horizontal shift is we take our function and we're either going to add or subtract to our x value before the parent function happens to it. So if our parent function is x squared, we're going to add or subtract from x before we square it. If our parent function is the square root, we're going to add or subtract from x before we actually take the square root. And the way we're going to write that with our notation here is that whatever our parent function is, the x is going to have something added or subtracted from it inside the parentheses. So before the parent function f happens to it, something is added or subtracted from x. Now you'll notice in this notation, the subtract is actually our default operation. It's not a plus sign. Additionally, you'll notice that we call this horizontal shift the letter H. That part of it is the most easy to understand because horizontal has the letter H in it, so we can go ahead and remember that right here. Horizontal has that H in it, so it's going to be easy to remember that if you see a letter H, it means horizontal shift. Another way that I remember horizontal shift is the minus sign that we put in the general form. That minus sign right there is a horizontal line. So when I see the minus sign, I know this is a horizontal shift and the original way that the horizontal shift was intended to happen. And the original direction that the horizontal shift is intended to happen is to the right. So if we see the negative sign, that means that we are moving to the right. And this is the part we said was counterintuitive. Usually when we see a minus sign, we want to move to the left, and a plus sign, we want to move to the right. But in this case, it's actually opposite. So if we see the same sign that was intended, that minus sign, that horizontal line, that means we're moving to the right. And then if we see the plus in there instead, that means that we actually subtracted from our negative and we actually added. So that's when we're moving to the left. So that is counterintuitive, okay? So that's the only one that's going to take a little bit extra brain work to remember because it goes against what we might naturally assume. We have a couple more types of transformations. The next one we're going to talk about is stretch and compression. And I know we talked about this during our review. In order to make something stretch, we have to multiply it. Multiplying makes our numbers grow in all directions, right? So what we're going to do to show that we're stretching a function in general form is we're going to take our function we are going to multiply it by some number out front, f of x times some number. We're going to call that number a. The way that we can remember that a means a stretch or compression is I'd like you to ask yourself the question, is it a stretch or a compression? I know it's not as fancy as the other ones because they actually had the letters or sounds in them, but if you ask yourself, is it a stretch or is it a compression, it'll help you remember that the letter A is what we use to multiply out front to show that this is happening, okay? And one final note about the stretching and compressing is that if we are stretching, getting bigger, it means that we are multiplying by a whole number. If we multiply things by whole numbers, they get bigger. So it's going to stretch up and down, okay? It's going to stretch this way, up and down. And the way that we can know if we're compressing is the same word as squishing, so it's getting smaller, is if we multiply by a fraction, because multiplying by a number that is smaller than 1, a fraction that is less than 1, if we multiply by a fraction that's less than 1, it is a very sneaky way of dividing, and dividing makes things smaller. So that is going to compress, and compression means up and down. We are going to squish this function together to make it smaller, up and down, okay? All right, and we have one more type of transformation that we kind of touched upon in the review, but we didn't get too deep into it. So this is called reflection, and reflection has two different directions that it could possibly go. The first one is across the x-axis, and this is the one that we looked at before. This is where we are inverting our function, and inverting happens when we take our function and multiply it by a negative. So -1 times our function is going to invert it. So that means that we are going to flip upside down. Whatever was on top will go on bottom. Whatever was on bottom will go on top. This is inverting, okay? The other type of reflection is across the y-axis. This is a side to side. So whatever was on the left will go to the right. Whatever was on the right will go to the left. And in order to show that in general form, y equals f of -x. So whatever those x values are going to change sign. And of course, negative x's are on the other side of the y-axis from positive x's. So it's going to shift everything from left to right. It's going to mirror image. So where a negative f of x is going to invert, f of -x is going to give us a side-to-side mirror image, okay? So these are all of the different types of transformations that could happen on a parent function. On the next slide, we're going to take a look at some examples of parent functions and their transformations, and we're going to take a look at the general form of writing all of these different types of transformations all together. So here at the top, let's go ahead and just take a look at one thing at a time. We have this form of our equation now. I would like you to write this down. These are examples, and we have to remember the general way that our function could change. So we could multiply it by a. Remember, that's a stretch or a compression. Inside with x, we could subtract h or add h. That is a horizontal shift. That's what that h is for. It's horizontal. And the plus k at the end means that we have a vertical shift. Vertical, okay? And vertical is that up and down movement. It's going to move the whole thing up or move the whole thing down, okay? So let's take a look at an example. Here's our first example. I would like you to draw this chart. So we have a list of parent functions. In the middle, we have a list of different transformations happening, and then it's our job to describe those transformations all the way to the right. So go ahead and get this copied down into your notes. You can pause the video if you need more time. I'm going to go ahead and talk about f of x equals x squared. That's a parent function that we should be pretty familiar with. We see that all the time. It's going to be a parabola shape, which is that curve, looks kind of like a smiley face. And in the middle, we have this transformation. You'll notice a few things are happening. If we compare it to the general form up top, a times f of x minus h plus k, we can see that there's some of these things happening here. We do have an a value. It's that 2 that's out front. We're multiplying it by 2. On the inside of our parentheses, that minus h, we do have this plus 3. It's not being subtracted, but it is inside with the x before the parent function operation's happening. So that squared hasn't happened yet when we're adding the 3 to the x. And then at the end, that plus k at the end, that's that plus 3 that we're looking at there. So we do have 3 different transformations happening in this function. And let's go ahead and take a second and describe all 3 of them. So the first thing that's happening in red, that 2 out front, that is a stretch, not a compression, because that's a whole number. So we have a stretch, so I'll write the word stretch, and the way we describe it is we have a stretch by a factor of 2. So we have a stretch by a factor of 2. So all of our outputs have been doubled, okay? Then in green, we have that plus 3. Now we know this is a horizontal shift, right? And we know the usual sign inside is a negative sign. So if we see the horizontal line, we know that this horizontal shift is to the right. But this operation has changed. It's become a positive. So this is a horizontal shift. I'm going to abbreviate that with HS. This is a horizontal shift that is to the left 3 units. Left 3 units, okay? So it's moved to the left. And last but not least, we have the plus k at the end. The plus k is our plus 3, so that k is the vertical shift, so we have a vertical shift. And because the plus k and the plus 3 are the same operation sign, they're both plus, that means that this vertical shift is up. So we're going to be moving up 3 spaces. So up 3 units. However you want to write that is fine. Let's go ahead and take a look at another example together. In our next example, our function is f of x equals the absolute value of x. If you remember those up and down lines on either side, that means absolute value. And the way we count the absolute values, we try to figure out how far that number is from 0. So all the negative numbers become positive numbers, and all the positive numbers stay the same. It doesn't matter if you don't know what this function looks like, or even how this function behaves, because knowing these base transformations, we can still figure out how our function moves knowing these transformations. It all works the same way no matter what our parent function is. So in this case, let's go ahead and take a look at some of the things happening here. We don't have a number out front of our function. We don't have a 1 or a 2, or, well, we don't have a 2 or a 3 or a 5 or whatever. We do have a negative symbol. So technically that is a -1, but it's not a stretch like, or a compression like a whole number or a fraction would be. It's a negative sign, which means that's going to be an example of a reflection. And because it is outside of the function, it is outside of those absolute value signs, because it's on the outside there, that means it's a reflection across the x-axis, because it's on the outside. So that's an inversion. It's going to flip upside down, okay? And then if we take a look inside the absolute value symbols, they work just like parentheses. This -3 is on the inside of our parent function, where we just had x before, and now we have x minus 3. So that is going to be a horizontal shift. And on the end, we do have the -4. That is going to be an example of a vertical shift, because that's outside of the parent function operation, outside of those absolute value symbols. So that means we're going to be moving up or down. So let's go ahead and describe those. First, we'll talk about the negative sign. Like we said, because it's outside of the parent operation, that is going to be a reflection. So we're going to say this reflects. So we have reflect across the x-axis. So that's going to be the up and down reflection. So I like to draw these arrows up and down like this to show that whatever was on bottom is now on top. Whatever was on top is now on bottom. That's supposed to be an arrow. It's really messy. There we go. So we reflect across the x-axis. The green portion here, that -3, the minus symbol is a horizontal line. So it tells me this is moving in the positive direction. Even though it's a minus symbol, it's moving to the right. So we are going to have a horizontal shift that is to the right 3 units, okay? So our horizontal shift goes to the right 3. And the -4 at the very end, is our vertical shift. Now our original vertical shift, that plus k, that vertical shift is usually up if we have a positive sign. This one's a negative sign, which means our vertical shift is actually going to be down. It is the opposite direction. So we're going down 4, okay? We've got one more example to look at together here. This last example, f of x equals the square root of x. You may remember what this parent function looks like. If not, we're going to talk about it in the homework a little bit, and then also in our lesson tomorrow. So the square root sign, again, we don't have to know what this looks like or how to use it. All we really have to do is apply these same transformations, and we're still going to know what happens to this function. So let's take a look at what's going on out here. We have a 1/2 in front of our square root sign. So that 1/2, even though it's a fraction, that is being multiplied. So that's going to talk about stretching or compressing. And because it's a fraction smaller than 1, that is a compression. So it's going to squish it down, top and bottom, and it's going to push it in toward the middle, okay? The square root symbol acts again like parentheses. So we have the x plus 2. That plus 2 is happening inside with x before the square rooting is done, which means that is a horizontal shift. And because it's positive, we just talked about that, it's supposed to be a negative symbol to move to the right. And so because that's positive, it's changed, we're going to be moving to the left 2 spaces. And at the very end, that plus 2 that's happening after the square rooting is done, that's going to be our vertical shift. So let's go ahead and talk about those with words. So the 1/2 is going to be a compression. So we are going to compress. It is a fraction smaller than 1. So that means all of our outputs are going to be cut in half. So we have a compress by a factor of 1/2. So that means everything is going to be smooshed down to the middle and compressed top to bottom, okay? So that's a factor of 1/2. The plus 2 on the inside is going to be a horizontal shift. And because it's a plus 2 and not the horizontal minus sign that we should see in there, that means that we are going to the left 2 units. And last but not least, the plus 2 at the end means that we do have that vertical shift. And the vertical shift is positive, just like that plus k in the vertical shift. So that plus 2 means that we are going to be going up 2 units. All right. So that is the end for this video for notes. At this point, you should have a worksheet with lots of different parent functions, transformations, and areas to describe. So you're either going to have to fill in the missing parent function, fill in the missing transformation, or fill in the missing description. And you'll notice there are also graphs on this worksheet, and I know we haven't worked with graphs together today, so if you can't do that portion this evening, that's fine. Tomorrow, we're going to talk about transforming pictures of graphs. But if you want to go ahead and try and see if you have any questions to write down to ask tomorrow, that's a very, very good plan, okay? Go ahead and get started on that if we still got time left in class.